Okay, things to remember. A function f is said to be continuous everywhere. Continuous everywhere if our function is continuous at every real number. In this case, we also say that the function is continuous on all real number. Again, a function is continuous everywhere. Letter B. On an interval a to b with parentheses, our function is continuous at every point of x in the interval a to b. For letter C, on an interval a to b where the a is a square bracket and b is a parenthesis, if the function is continuous on an interval a to b on the left and from the right at a, it means that okay, assuming our graph has at x which is equal to negative 1 is undefined at x equal to 1 is also undefined. It means that the graph has a white dot or a hole. So if our interval looks like this one, so for instance, we will start from negative 1 to 1. So as we evaluate it, we will start at exactly at a, which is equal to negative 1. So we will start from negative 1 and we will end at the value of x, which is lesser than 1, because our bracket here is still a parenthesis. Now, if we use a square bracket, it means that the value of a is included. Now, if we will use a parenthesis, we will start to evaluate at x is greater than the value of a. So it means that if we use a square bracket, we will start at negative 1. But if we use a parenthesis, we will start from negative 0.99999 and so on. So for this example, from an interval a to b, our function is discontinuous from negative 1 to 1. Okay, but on an example here, from an interval a parenthesis a to b parenthesis, our function is continuous. Okay, for letter D, on an interval a to b, now this time our b has a square bracket. So it means that we will stop at exactly x is equal to the value of b, which is for this example at 1. But for C, if our b is on a parenthesis, our x is lesser than the value of b, or for this example, which is 1. So as we evaluate it from a to the value of b, we could say that our function is discontinuous because at exactly x is equal to 1, our graph here is a whole or undefined. Okay, for letter E, so we will start from a square bracket A and we will end to a square bracket B. So it means we will really start from x is equal to A and we will end to x is equal to B. So for this example, since the A is an undefined and B is undefined, therefore our interval is discontinuous. Okay, so on f on the interval a to infinity, if our function is continuous at all value of x which is greater than a. So it means since this is a parenthesis, we will not include the a. Okay, whatever the value of x which is greater than a. Next is on g on interval from a to infinity, if our function is continuous from a to infinity and from the right at a. So it means all values of x which is greater, and since this is a square bracket, we will include the value of a. So from -1 to positive infinity. Same thing holds true on letter H, which is from -infinity to b if f is continuous at all values of x, which is lesser than b, and on I from -infinity to b is square bracket if it is continuous on infinity b, and from the left at b. Please keep this on mind because this is very important on the topic and in the continuity on a function on an interval. Okay, another thing to remember, the continuity of polynomial, absolute value, rational, and square root functions. Our polynomial functions are continuous everywhere. Again, if our function is a polynomial function, all values of x in a domain of x, it is continuous. Okay, x is the absolute value function of f of x is equal to the absolute value of x. Still, it is continuous everywhere. So for a and b, it means that our function is continuous from -infinity to positive infinity. There is no discontinuity in any part of the or domain of x. For letter C, rational functions are continuous on their respective domains. So there are things in which the value of x is discontinuous if our denominator of a rational function is equal to 0. So remember this, is if our denominator is equal to 0, our rational function is discontinuous at that point. While for the square root function, it is continuous on the interval from 0 to infinity. It means this is a square bracket, so it means that 0 is included. Since we cannot take a negative value on the radicand or whatever value we put in the inside the radical sign, so we better see that the value of the function inside the radical sign doesn't go less than 0. Okay, example. We will determine the largest interval over which the function f of x is equal to x plus 2 is continuous. Now, since the x plus 2 is a polynomial function, we can conclude that the function is continuous everywhere. So the largest interval is all values of x, which is an element of a real number, or we can write this from -infinity to positive infinity. That is the largest interval in which the function is continuous. You can see it on the graph of a function that it is continuous from -infinity to positive infinity.